So the main activities of the verification process consist of performing reviews, performing analyses, and of course perform tests. So if you look at the reviews, we really try to qualitatively assess the correctness of the process or component. So we try to do these reviews of the requirements, the high-level requirements, for example, of the design, the low-level requirements in software architecture, of the code, maybe code run-throughs or code reviews, and of course of the test procedures. So you try to have reviews of all these artifacts that you're generating in these particular cases. And of course in that cases, for your reviews, you can make pretty effectively use of checklists, where you say, okay, what is it that I need to look for in the requirements or in the design documents or in the code reviews? What are the items that I need to look out for? So if you use checklists, you can check out if you truly did that, and it can guide you in doing it efficiently. Yeah. So this, as I said here, objective evidence of the review activity. You focus on the areas most prone to error. These are you have a mechanism of lessons learned, and you can also have a simple means for assuring corrective action. So that's the reviews. The second verification activities are the analyses. You really now start to examine in detail the functionality, performance, the traceability of all these software components. So you start looking at, okay, what is the data flow, for example, from one module to another? What's the control flow? You're going to analyze timing, or its use of memory. So if you only look on the lack, and a couple of activities that are, a couple of analysis activities would be checking out what the worst case execution time is throughout your program. How much margin you have in terms of memory. Are you going to run out of memory? You're going to say, okay, how are you going to map your memory? Is it going to be safe? You're analyzing your interrupt and your interrupt mechanisms. And of course, more basically, you can analyze your math when it is math that you're trying to represent, like we, for example, do in the projects that we have. Then, of course, second of all, you're going to just analyze, the errors and warnings that you generate, and the partitioning. So these are a couple of the example analyses. So the third verification was testing, and we'll talk about that some more towards the end of this section. So if you look at the topics of review and analyses, I've broken it down according to the buzzwords, the attributes that you saw mentioned in the objectives, like compliance and traceability, and we've talked about this before. Conformance, you're conforming. So remember, compliance really, it's technically in technical agreement with an earlier life cycle item. Traceability means you can actually trace it back to an earlier life cycle item. And conformance meant that it's in agreement with what you actually promised in the standards. Now, a couple of additional items that we have not seen in previous modules is consistency, accuracy, verifiability, and compatibility. We'll talk about each one of those just in a little bit more detail. Verifiability, we kind of already talked about it when we talked about the systems engineering module, but we really ask ourselves the question, can we verify this particular requirement or code piece without any change? Yeah. For example, and this of course applies to high-level requirements, low-level requirements, software architecture, and source code. For example, if you have a requirement that says a red indicator light shall come on if the electrical power falls below 3000 watts. Well, in this case, we can verify this by tests. We can actually, connect it to the device, and we can check, reduce the power and see if the red indicator light truly comes on when the electrical power falls below 3000 watts. So we can truly do this. But accuracy means, the requirements that are written, are they accurate? Are they unambiguously stated? And do they have sufficient detail? Now, some cases can also happen that they have too much detail, but you want to make sure that they're unambiguous. And for example, a couple of bad requirements: the aircraft shall hold altitude. This is really very unambiguous. So very ambiguous. Yeah. Where should it hold altitude? With what tolerances? When shall it hold a particular altitude? There's not enough details here to actually warrant this requirement to be accurate. If you have the system shall detect asymmetrical thrust whenever the aircraft is on the ground and below V1 speed, in this case you may want to wonder a little bit about, okay, do we have sufficient information to understand what this requirement really means? So we saw verifiability. Can we test it without change? Accuracy, is it accurate, ambiguous, unambiguous, and sufficiently detailed? And the last item is consistency. Or not the last item. That means, is there no internal conflicts within a collection of items? You may have multiple requirements in which you state a particular function or action that are not necessarily consistent. They're not in agreement. For example, if in one item you say the number of transmitted synchronization bytes shall be greater than 140 bytes per second, and if you then say the synchronization bytes output by transmitter shall not exceed 7,000 per minute, if you would actually taken these bytes, so 7,000 per minute, if 7,000 divided by 60 is a little bit more than 100 per second, is not necessarily consistent with the earlier requirement that you have. Actually, they're mutually exclusive in this particular case. So that means there is an inconsistency that you need to kind of either find by means of review or by means of analyses. You need to find that this is a problem and then feed it back to the requirements process and fix it. So the compatibility is really to check out if there's no conflicts between two or more specified items or collections. In other words, compatibility of a particular executable code with the hardware target. Now finally, of course, we saw that there was this other table that looked at the review and analysis of the outputs of the integration process. So we really want to make sure that the integration process, integration of all the software modules, and then the integration with the hardware, that's complete and correct. And actually, let me also say the second item here. So you want to make sure that all the hardware addresses are correct. You need to know your hardware platform, and if you address particular memory locations in that hardware that represent, for example, I/O device, you need to make sure, by means of review and analyses, that those are the correct ones. Now, an example that I gave here is the FADEC example. In this case, FADEC is a full authority digital engine controller. So it reads out the low engine rotor speed, NL, in % of maximum revolutions per minute. And then in this case, and this comes from DO246A, frequently asked question 35. It gives you 3 examples, one for a system requirement, one for a high-level requirement, one for a low-level requirement. And you see that the FADEC shall detect and accommodate the NL signal for open and short circuit failures and range failure per hardware-dependent software requirements, specification, limitations. So if you look at these can be verified. You can say, well, I would generate a high-level test that sets up an engine simulation to run at idle speed, and then open circuit the NL signal and check if the faults recorded and enunciated. So you can come up with a test for this requirement. And the same for this high-level requirement and low-level requirement. So this is part of the verification process. You look at these requirements and you say, can I test them? And of course, later on, we'll see DO178C has this thing called requirements-based testing, where you use a requirement to make the test cases. So when you write a requirement, you can already start thinking in terms of, what kind of test cases would I have to write to test this particular requirement? Or what kind of test cases I have to design to test this requirement? And again, here you see the 2 test approaches or verification methods for the other 2 test cases.